Now let's see how Java achieves platform independence without affecting execution speed. We discussed about compilation and interpretation, which offer contrasting benefits and limitations. We have seen that with compilation, we get fast execution speed, but without the benefit of platform independence. On the other hand, with interpretation, we get the benefit of platform independence, but with much slower execution speed. Java uses best of both the worlds. That is, it uses both compilation and interpretation to achieve platform independence, but without compromising on speed. And this is how it is accomplished. Java source code is first compiled into an intermediate form called the Java bytecode. Java bytecode can then be interpreted on any platform with a JVM, which stands for Java Virtual Machine. Like in the case of an interpreter, on each platform, JVM specific to that platform is installed. Let's look at this process in some more detail. Let's assume we have a Java program called hello.java, which includes the source code. Hello.java is then compiled to generate hello.class, which includes the Java bytecode. To compile, we use the command javac space hello.java. So javac or javac, as it is often pronounced, is the Java compiler. Hello.class can then be executed on any platform that has a JVM installed. As we can see, JVM is specific to a platform. That is, for Windows platform, we install a JVM specific to Windows. Now to execute the class file, we use the command java space hello. This command creates an instance of JVM. That is, the CPU loads the JVM into memory and then the JVM executes hello.class. As you can see, JVM is platform dependent, but Java bytecode is platform independent. This whole process is pretty similar to interpretation. If you recall our discussion on interpretation, we were using interpreters to directly execute or interpret source code. Whereas in the case of Java, we are using JVM to interpret bytecode instead of source code. So JVM is the interpreter. In fact, the actual interpretation is done by Java interpreter, which is a subcomponent of JVM. So as JVM is interpreting Java bytecode, we can think of Java as an interpreted language. Okay, so we looked at platform independence benefit of Java, which is due to its interpretation process. But we know that interpretation is slow. So how does Java ensure that it is also fast? The key is that interpreting Java bytecode is much faster than interpreting source code. And this is because bytecode is compact. Moreover, it is already compiled, which means things like syntax and semantic checking are already taken care of. Also, bytecode is optimized. To further speed up execution, JVM also performs additional optimization through a process called just-in-time compilation, or JIT compilation for short, which will be discussed when we cover JVM. Note that Java bytecode's compact form also enables quick transfer of bytecodes across networks. Recall that Java was originally designed to work in a networked environment, where transferring compiled Java programs across different devices was one of the goals. So that's about it, and we have seen how Java bytecodes and JVM were used to achieve platform independence without compromising on speed. Okay, before signing off, let's actually go ahead and test the platform independence capability of Java. So here I am on my Windows machine and I have this program hello.java, which is similar to the hello.c program which we have seen in the platform dependency lecture where we were printing the text hello world. So this class also prints the text hello world onto the console. So let's go ahead and compile this Java program. So to compile, as I said earlier, the command is javac space hello.java. And it would create a .class file, hello.class, which contains the Java bytecode. So in order to execute it, we say Java, which is the Java interpreter, and it would be space hello. And that would execute the hello.class, which has the Java bytecode. And as you can see, it prints the text hello world. Now let's go ahead and copy this .class file, which was generated by the Java compiler, onto the Linux machine in order to test the platform independence capability of Java. So here is hello.class, which was generated by the compiler and which has the Java bytecode. So I copied it onto my Windows machine. Next, let me just execute that. So we don't have the compilation step here, just execute it. Java space hello. Okay. That's it. So it also prints hello world and it shows that Java is platform independent. Okay, so that's about it. Thank you and see you in the next lecture.